In the previous video, we have seen how to clone a GitHub repository containing a plugin so that we can compile that plugin as part of our project. The plugin in particular was the text asset plugin. Again, you can find it on the GitHub website under UE4 plugin/text asset. And if we look at the Visual Studio solution and we check out the folder structure for the text asset plugin, we will recognize that it's a little more complex than the very basic plugin that we had created in the beginning, but the directory structure is still pretty much the same. There's still a resources directory, and initially it only has the icon that's going to be shown in the plugin browser. And then there's also a source directory that contains all the source code. Now, this time, instead of having just one module, we actually have two modules. There's one called text asset, and one is called text asset editor. And the reason I did this is because there's some functionality in this plugin that's only meant to be used in the editor. And then there's other functionality that is shared in the editor and also in the actual game. So everything that is editor only, I put into the text asset editor module. So this plugin adds a new type of asset, and we've seen there's a context menu action, and there's some drag and drop support, and there's a way to create these types of assets. Let's take a quick look at some of the things that we need to do to add a new type of asset to UE4. And when you create new asset types for UE4, it can be a very simple task, or it can also be very complex. It really depends on the type of asset you're creating. If it's something like the text asset that I'm showing in this video, things are very, very easy. If you look at an asset like the material, for example, or textures, or static meshes, or animations, things can get much more complicated. But there are always some basic steps that, no matter how much functionality your asset has, these basic steps always have to be taken to add assets into the engine. And the first thing you got to do is to actually declare the C++ type for that asset. In this case, there's a C++ class for the text asset itself. And then you have to have a way for users to create instances of this new content asset. And we do that using so-called factories. And then the next thing you probably want to do is to customize the look and feel of your assets in the editor. The things I've shown you, like the context menu actions, also the little thumbnail and the colors of the thumbnail. All those things can be customized, and I'll show you how to do that as well. And then lastly, there are also content browser actions that you can perform. Now, by default, when you create a new asset and you double-click it in the content browser and you open it up, it will just show a details panel. And the contents of the details panel are created for you automatically by the editor. The editor basically looks at your asset type declaration, and it automatically extracts the information that it needs to build a basic details panel UI, where you can configure all the properties of your asset object. But in some cases, especially with more complex asset types, you may also want to replace this default behavior with a whole new custom asset editor user interface. For example, the blueprint editor and the material editor, those UIs are actually custom asset editors. All right, so let's take a look at some of the code. The first thing I want you to see is the declaration of the text asset class itself. And all asset types are what we call UObjects. If you are familiar with more modern programming languages like Java or C#, you are probably familiar with features such as automatic serialization and runtime introspection and garbage collection. And C++ doesn't really provide any of these out of the box. But of course, they're very convenient, and we would still like to have those features as well. So we built a little framework on top of C++ that allows us to do that. And this framework is called the UObject subsystem. So a text asset is really just a regular C++ class that inherits from UObject. And you can see it's declared right here, UText asset. By the way, all UObjects, they start with the letter U. You will see that everywhere in the engine. U means it's a UObject derived class. And this is not just for style, it's actually required that you prefix it with a U. Similarly, if you derive from actor, your class name will have an A prefix. And then everything else in the engine is usually prefixed with an F. There are some historical reasons for that. I don't want to go into those details right now. And then you see the only thing that this class declares is a single field called text. So this is where we store the text. And let's break this down into a little more detail. So this is how we start out. This is how we declare the class. UText asset derives from UObject, has a single field called text. There are some header files we need to include because we're using some other types, such as UObjects, and also ftext. They're declared elsewhere, so we got to include them. And this macro here, by the way, this text asset API, this is generated automatically for you. For like every time you create a new module, there's going to be a macro declared that's the same as the name of your module, all uppercase, and then underscore API. And all this does is it basically exports this type out of your module so it can be used in other modules. So then we add some other macros to this class declaration, and this is what provides these more modern features that I mentioned earlier. The uClass macro, it tells the Unreal Build tool that this class is a UObject-based class that needs to be parsed. So UBT, or to be more specific, its subcomponent Unreal Header tool, UHT, will actually parse all the header files and then look for these macros, and if they are present, it will automatically generate all the glue code that is required to provide things like serialization and garbage collection and runtime introspection, etc. This code is all generated into a file that ends in generated.h. That file has the same name as your class, minus the u, plus the .generated.h. And let's take a quick look so you get an idea what it looks like. I'm going to open up text asset, and let's see, open this document. All right, so you see there's a lot of mumbo jumbo in here. It looks crazy. The good news is that you will almost never have to look at this, ever. I've worked with Unreal for 20 years, and I had to look at this maybe 5 times. So you can just assume that it works. All right, so that's where all the magic glue code goes. And then the next thing is to integrate our asset with blueprints, and that's just as easy. We use some special attributes that we can add to our macros. In this case here, in the uClass declaration, we are using the attribute blueprint type, and this will cause UBT to generate code that makes this asset type available in blueprints as well. Similarly, we're exposing the text field in blueprints as well. And here, just for demonstration purposes, I decided to make this a read-only field. So in Blueprint, you can only read from this field, but you can't write to it. All right. So if you look up any of these declarations of these macros, you will notice that they're all empty. They don't actually do anything. These are just used as keywords for Unreal Header tool to parse, so it knows when it needs to generate code for you. All right, then that's really all there is to it. Now we have a new asset, and we need to give users the ability to create some instances of those. And the mechanism we have for that are called factories or asset factories. And asset factories are also C++ classes. They are inherited from a special type of UObject. It's called a UFactory. And that's really the base class for all kinds of asset factories. And a lot of the functionality that you need, such as drag and drop support, is actually already implemented in the editor, so you don't have to worry about that. The editor will basically just call into your UFactory class. There are some functions that you can override when it needs to perform certain actions, and then you only write code for those particular actions. And 90% of the rest of the boilerplate that is needed is already implemented for you. And you will usually see 3 different kinds of asset factories. There's the factory that provides the integration for the context browser context menu. That's when you right-click in the context browser, in the content browser, and you see all the different types of assets that you can create. Then there's usually a separate factory for drag and drop support. And then sometimes you will see also separate factory classes that handle automatic reimport, although lately reimport is mostly handled as part of drag and drop. Reimport basically allows you to monitor the file system automatically for changes to the file that you originally dragged and dropped into the content browser. So if I did not implement reimport for this tutorial, but if I did, then let's say if I changed the contents of my text file on my desktop and I saved it, then an automatic reimport factory could detect that change and would then recreate the asset with that modified text. Okay, so here's a quick glance at the 2 different types of factories that I did implement. And again, here's the content browser context menu, and the corresponding code for that factory's declaration is in text asset factory new. In this case, since factories are an editor concept, you actually have to go inside the editor module, and I created a subdirectory called factories, and there's the declaration. And you see it's pretty simple. There's not really a whole lot to it. I'm just overriding 2 virtual functions, and that's it. So let's take a look at those functions in more detail. The first is factory create new. This is the function that will actually be called by the editor when a new instance of that asset type is to be created. So when the user right-clicks in the content browser and then selects text asset to be created and left-clicks, at that point this function will be executed. And you see it's pretty straightforward. We're just creating a new object of type uTextAsset. The second function is should show a new menu, and that basically just makes the text asset show up in this menu. So the fact that this entry here down here shows up there is because we're returning true. And there's a little bit of initialization needed in the factories constructor. We need to tell the editor that our factory supports assets of type uTextAsset. And we also got to tell it that this factory will create a new instance rather than drag and drop. And we also want to be able to edit the name of the asset after we created it. Now, the factory API is pretty old. I think it's at least 15 years old, and it's a little archaic. So some of the things that you got to do here are just you know, for historical reasons, and we didn't have time to clean it up yet. Hopefully, in the near future, we will have a chance to modernize the factory API. And these flags are also the reason that you need to have a different factory class for each type of factory. You may be wondering, why can't I just have a single factory that can handle the context menu, the automatic re-import, and the drag and drop? Well, it's just because it's a really old API, and perhaps someday we get to fix it. Okay, and then the other factory that we have is the one for drag and drop. And the declaration for that one is even simpler. You see, in this case, we're only overriding a single method called factory create binary. And that will be called by the editor the moment we release a file into the content browser. Here's the implementation. It's very similar. Again, there's some initialization needed in the constructor. In this case, we need to tell the editor that this factory supports files with the file extension txt. And this time we have to change these flags and mark it as a drag and drop import factory. And then the function to actually create the asset, instead of simply creating a new object, we actually load the file from the disk. The current file name is being passed in. We're loading it from disk into a string, and then we're converting that string into a localized text, which we can then assign to the text assets text field. Now, you might notice in this particular API, this is the older version, we're actually already getting a copy of the file's contents. If we go into the declaration here and we can see the entire thing for create binary, we will see that back here we're already getting a buffer and also a pointer to the end of the buffer. So the editor is actually already reading the file for us, and it seems kind of wasteful that we're reading it again here. So we recently added a new API that will actually just pass through the file name and not load the entire file into RAM. That can be a real problem. For example, I recently wrote an asset for media sources such as videos, and those can be very big files, and dragging and dropping one of those into the content browser can take 20-30 seconds before something happens. In that case, we really just want to load the string. And that new method is called factory create file. It's very similar, but it only passes through the file name. And here's the updated version of the same code. And this is, in fact, the code that we're currently using in the version of the GitHub repository. All right, so that's it. You now should have a basic idea of how to create assets and how to create factories that allow those assets to be created. The assets themselves are just basic UObject derived classes that can very easily be exposed to blueprints using attributes. And then the features such as the context menu and drag and drop and automatic re-import is all handled via asset factory classes. And one really cool feature is that you don't actually have to do anything else besides declaring those factories. The mere fact that they are derived from uFactory will make them auto-discoverable by the editor. So they auto-register themselves and things just work. Okay, so that was it. In our next video, we are going to look into how to customize the look and feel of our new asset types.